Hi guys, welcome back. So this is the second part of the second question of week 11. So let's see the problem statement what it says. So the problem statement what we have to do in this is basically pre-processing and model training. So regularization and evaluation. So we have to do four things. So let's see one by one. First is a feature selection. We have to choose whatever features are relevant to us to this model. Now we have to handle the missing values. If there are any missing values, we have to handle them as well properly. And then we have to encode all the values between 0 and 1. So we have to encode it. We have to use it. So basically we have to encode using one-hot encoding the features. And then we are splitting between test and train. Then build a model. Here we are building decision tree classifier, and then we have to evaluate it and then apply regularization. So we have two types of regularization here. L1 is lasso and L2 is ridge. So we'll see both. And let's move on to the code. So we are importing several things here. So basically one is pandas. Second one would be test train split to evaluate. Then the third one is decision tree classifier. As I said, we're using decision tree classifier here. The fourth one is confusion matrix. And now then we have the logistic regression we are importing. And then we have standard scalar. This is basically used to reduce the terms between 0 and 1. So then standard scalar, this is used for normalization, that is mean equal to 0, standard deviation equal to 1. So let's see the first function what we're doing. The first function says select features. So the function is select features, and here we are selecting the features what all is required, that is age at enrollment, gender, they are in debt or not, tuition fees up to date, and curricular units from first sem, that is approved. So and then we are putting all these in X. So then this is the first function. Second function is basically handle missing values. So if you handle missing values, and we're creating a copy of the dataset. We're not directly handling it in the main dataset. We're creating a copy of the dataset, and then we're using all the categories and all the columns which we're using, and then we're storing it in a copy of X. We are basically adding a new column called categorical columns, and then we're adding the whatever is unknown. And then one more is missing. So basically what we have to do for the missing values is basically we're adding the median. Where we're adding the median is to take care of the outliers. If we add mean, then the outliers would be more. So we are adding median. So after this, we have to encode it. So we are creating a function called encode categorical features, and in this we are selecting the categories, and then we are encoding it. So basically we are giving the whatever columns to be encoded, and then we are encoding it. So and then we are dropping the first one to make it simple and not to then we are dropping the first to avoid errors. Okay, so then we are splitting the data. So here what are we doing? Basically we are using 70-30, not 80-20. 70 is for training and remaining 30 is for testing, with random state 42 again, so that the data won't get shuffled. It remains the same. And then we have four parts: X train, X test, Y train, and Y test. So then we are using the decision tree model. So here what are we doing? Basically we are using decision tree model with random state equal to 42. Then we are fitting it. Basically we are training the model, and then the model returns the output. Then we have evaluation technique. So evaluation, we are finding predicted value of y, accuracy, confusion matrix. So all these three things we are finding using evaluating model function. And now comes L2 regularization. So basically I showed it to you. So basically L2 is ridge regularization. So what happens in L2 is basically it reduces but never takes it to 0. So it never touches 0. So we have all the features remaining as it is. So first we are basically normalizing it, and then we're normalizing the same thing for both train and test data, and we're converting it back into data frame from the arrays, numpy arrays. So both, and then we are using the logistic regression. So basically we are using the L2 model, the so basically we're using the ridge model with random state 42 and iterations is 2000. Now we have the model is we'll train the model as well. So similarly we're doing the same thing for L1 regularization, that is lasso. So the same thing, everything is the same except the solver model. So here we don't have any model. Here this model is Saga. So again the same thing, maximum iterations 2000, and then we are training that model as well. Now we'll move on to the main function. So one more thing, in lasso it can take the value to 0. So we can miss a few features, so that we have to keep in mind. Now in the main function, we are loading the data set, representing the data using all the small functions what we did, and then we're adding a target. So basically we're making sure that auto output label, the target is the correct column for that. Now we're splitting the data again, then the decision tree model we are using, and then we're getting all the features out, like all the evaluations out. So then we are applying L2 and L1 regularization. We're finding the accuracy of both, and then we're printing the accuracy. So that's it. Let me run this code and show you. Okay, so basically decision tree accuracy is 0.66, and ridge model accuracy is 0.6634, and regularization of lasso is 0.66634. So you can observe both of these are same, and this is slightly better than that. Now I have the confusion matrix as well. So that is it for this video. I can submit this. Let me check. Okay, so we have cleared the problem successfully and move to the next problem. So that's it for this video. I hope you guys have understood. If you want to try this on your own, then head to the CodeChef platform right now and give it a try. If you have any doubts, then let me know in the comments below. I'll see you in the last video of this series. Thank you.